Hi everyone, my name is NAVIN. My matrix number is BEEZ1213. Today I'm going to present about the topic A multimeter technology. This is a analog emitter, DC emitter. So this one is going to measure electric current in a direct current DC circuit. So for this to measure the flow of electric charge in a single direction, which is character of DC system. The unit for measurement for electric current is ampere. Ammeters are calibrated to provide readings in amperes, and modern digital DC ammeters used for electronic components and microprocessors for precise measurements. And the advantages of DC ammeter, so provide accurate measurement of direct current without the need of additional circuitry. And the second one is a low power consumption for the making them efficient for continuous monitoring of current flow. And this one is direct reading of the current flow, easy to interrupt the measurement without the need of additional calculations. And the second one is DC voltmeter. This is analog voltmeter. This one going to measuring instrument used to measure the DC direct current voltage across an electrical component or in an electrical circuit. Provide an accurate reading of voltage level. And the third one, so voltmeter and monitor electrical system, troubleshoot problem and ensure proper voltage level for the safe operation of electronic device and equipment. And the advantages of DC voltmeter is provide accurate readings for DC voltage level accuracy and stable and less susceptible to fluctuation compared to some AC voltmeter stability is advantages when measuring constant or slowly changing DC voltage. Easy to use and making them suitable for various applications. And the third one is multimeter. This is the multimeter story. So the multimeter can measure voltage, resistance, and current, which can be used as voltmeter, ammeter, and ohmmeter. The analog multimeter is used as a microammeter with a moving pointer to display readings. Digital multimeter have numeric displays. And the advantages of multimeter: multiple measurement functions in a single device, like measure voltage, current, resistance, continuity, capacitance, frequency, and sometimes temperature. Then the second one, easy to read digital displays and safety features to protect the user and the equipment. And this is the two types of multimeter: digital multimeter and analog multimeter. And the multimeter in the market and prices is, the first one is unit digital multimeter. This one is priced 106 ringgit 55 cent. The second one is analog multimeter. It's the price is 135 ringgit. So that's all from. Thank you.
Hello everyone. Now I'll explain about the oscilloscope technology. An oscilloscope is a measurement device that mainly displays the waveform of electronic signal. It is used to measure AC and DC voltage, AC and DC current, time, phase, frequency, and also other electronic parameters. It is often used by engineers to measure electrical phenomena and solve measurement challenges. The cathode ray oscilloscope, which was the first oscilloscope invented by a German physicist named Carl Ferdinand Braun in 1897. This cathode ray oscilloscope produces an image by causing a focused electron beam to travel in pattern across the face of the cathode ray tube. There are two types of oscilloscope, the analog oscilloscope and also the digital oscilloscope. This is the basic block of the CRO oscilloscope, which consists of cathode ray tube, also known as the heart of the oscilloscope. Consists of electron gun, vertical deflection plates, horizontal deflection plates, and also the phosphor screen. The other blocks are the vertical amplifier, horizontal amplifier, delay line, time-based generator, and also the power supply. This is the main architecture of the CRT, or the cathode ray tube, which consists of electron gun, which produces the electron beam towards the phosphor screen, horizontal and vertical deflecting plates, which controls the electron path of the electron beam, the phosphor coder screen, which glows visibly when it's struck by the electron beam. Next is the latest technology of oscilloscope. The first one is high bandwidth and sampling rate. Second is liquid crystal LCD, which is more compact than cathode ray tube. Cloud connectivity, which allow user to store, share, and analyze data. Compact and portable, and also advanced triggering option. These are some of the oscilloscope in the market right now. The first one is the Keysight Technology DSO X3104G, which has a bandwidth of one gigahertz. Channels, there are 4 channels and also 8.5 inch of touchscreen display, which costs around 100,000. Next one is the MIC oscilloscope, which has a bandwidth of 500 megahertz, consists of 4 channel, 14-inch full display with a higher resolution. It also has 32 GB of built-in memory for waveform and video recording. It also has a battery life up to 5 hours, and it's lightweight, only 4.3 kilos, and it costs around 20,000. Thank you very much.
Hi everyone, I am going to talk about sensor technology. The first sensor is piezoelectric transducer, also known as piezoelectric sensor. This device used to measure changes in acceleration, pressure, strain, temperature, or force by converting them to electrical charge. The operational principle of a piezoelectric transducer is based on direct piezoelectric effect. The transducer experiences mechanical deformation such as compression or tension. The piezoelectric material deforms and generates a voltage across its surface. The electric voltage produced by a piezoelectric transducer can be easily measured by voltage measuring instruments. Then, for the parameter equation, for the sensor, I have two formula, one for longitudinal effect, which is Q equals to T times F, and transverse effect, which is Q equals to T times F A over B. The described equation for this equation is Q is the electric charge generated, and D is the piezoelectric charge coefficient. A is the area of the piezoelectric material, B is the applied mechanical stress, and D it is charge sensitivity of the crystal, which is T equals to 2.3 times 10 negative 12. And the voltage can be related to the charge Q through the equation V equals to Q over C. For the application for piezoelectric transducer are used as sensors in variety of applications such as medical, aerospace, nuclear instrumentation, inkjet printers, ultrasonic transducers, actuators, energy harvesting, and as a tilt sensor in consumer electronics. Overall, the versatility of piezoelectric transducers makes them valuable in various fields. Thank you.
Okay, hi. In this video, I want to explain about the thermocouple sensor. So here we can see the basic construction. So the thermocouple sensor is a temperature measuring device. It's consisting of two wires of different metal joint at each end. One junction is placed where the temperature is to be measured, and the other is kept at a constant lower temperature. So here we can see the thermocouple demo picture and also the thermocouple working picture. Okay, here we can see the operational principle. So when two dissimilar metals are connected, a small voltage called a thermojunction voltage is generated at the junction. This is called the Peltier effect. If the temperature of the junction changes, it causes voltage to change too, which can be measured by the input circuits of an electronic controller. The output is a voltage proportional to the temperature difference between the junction and the free ends. This is called the Thomson effect. Both effects can be combined to measure temperature by holding one junction at a known temperature reference junction and measuring the voltage. The temperature at the sensing junction can be deduced. The voltage generated is directly proportional to the temperature difference. The combined effect is known as the thermojunction effect or the Seebeck effect. This is the parameter equation. The parameter equation is thermocouple can be expressed as V equals to S TH minus TC. So here we can see the V is generated voltage, S is Seebeck coefficient, which is a constant for a specific thermocouple type. Then TH is a hot junction temperature, and also last one is TC, cold junction temperature. Okay, this is the applications. So first one is we can see the temperature measurement. Thermocouples are widely used for temperature sensing in various industries, including manufacturing, food processing, and HVAC systems. So the second one is industrial processes. In applications where temperature monitoring and control are critical, such as in chemical and petrochemical industries. So the just now we can see at temperature measurement HVAC, the full form is heating, ventilation, and air conditioning. So the third one is the one heating, ventilation, and air conditioning. Thermocouples are used to measure and control temperatures in heating and cooling systems. The fourth one is aerospace. In aircraft and spacecraft, thermocouples are utilized for temperature monitoring in engines and other critical components. The last one is household appliance. Some household appliances like ovens and stove tops use thermocouples for temperature control. Thank you. That's all.